Good morning, ladies and gentlemen, and welcome to Global Compliance Panel's live webinar on Leadership in Manufacturing Contamination Control. My name is Michael, and I'll be your host for today. On behalf of the Global Compliance Panel team, I'd like to thank you all for being part of this event. Today's webinar is being presented by Mr. Terry C. Solly. Terry has a PhD, and he's also a microbiologist and president of Solly Pharma Solutions Incorporated. And since becoming a full-time consultant, Terry served consumer products and FDA-regulated industries with training and troubleshooting expertise covering water systems, sterilization, aseptic processing, microbiological, and beta-lactam contamination control, and has served as a pharmaceutical expert witness in several contamination litigations. Prior to full-time consulting, he's had over 25 years of diverse big pharma operating company experience. During his 31-plus-year career, he's lectured extensively at conferences, authored numerous papers, and recently has also written several book chapters related to water system microbiology for USP, PDA, and ISP publications. He's currently serving in his third 5-year term on USP expert committees responsible for pharmaceutical waters, through which he's authored the complete rewrite of USP chapter, which many consider to be USP's pharmaceutical water Bible. We are honored to have Ms. Terry C. Solly with us to present today's webinar. Ladies and gentlemen, quickly before we begin, I just want to inform you of the program outline for today. This webinar is for a 90-minute duration. First, Terry will take you through today's webinar, highlighting the areas that he would cover, and then share with you his presentation. And also, I want to inform all our participants that once part of the teleconference, you've been placed in mute and would remain so until the Q&A begins, which would be towards the end of the webinar. This is again just to ensure that there is no discontinuity while Terry speaks, and that all of you could take maximum benefit from this webinar. And I also request all of you to hold your questions until the Q&A begins. You have about 10 minutes of time at the end of the session. And for any reason, ladies and gentlemen, if you do get logged out of the session, please follow the same procedure to join in again. Now that we're all ready, I do request Terry to take it from here. Terry?
Thank you, Michael. Welcome everybody, and good morning or good afternoon, depending upon what coast you're closest to. I beg your indulgence here a little bit since I'm battling the umpteenth cold I've had this season, so I may have to clear my throat every now and then, in which case I'll try not to blow your eardrums out in the process. But anyway, we are all here today to learn a little bit more about leadership in manufacturing contamination control. Now, specifically, what we're talking about here is the Microbiology Lab, because it's my firm belief that the Microbiology Lab should be the hero of a manufacturing situation for contamination control for a lot of reasons that we're going to go into. If you see on the screen right now, not only is my website shown, but also the fact that I've been involved with USP for a lot of years now. And Michael alluded to that in the bio. But I wanted to make sure that everyone knew that I am not speaking for USP. I'm a private citizen. I'm actually an unpaid volunteer working with USP. And so I cannot and am not representing USP in any way today. The opinions that I express are my own, although you may see some consistency with what USP says as well, since I had a lot to do with the words that are in there right now. So anyway, getting along with the presentation, this is what we're going to be talking about today, how contamination is controlled, and why the Microbiology Lab should be the leaders in contamination control. We're going to talk about some routine contamination evaluation activities that they are already involved in, microbiological training activities they're involved in, often the root cause and impact investigations that they are already involved in, but we're also going to talk about some impediments that they face to leadership in this regard. And I'm going to give you some of my own observations relative to the locations that I see contamination occurring. As a consultant, I do a lot of mitigation of contamination of companies, and I mean, that's what I do. And often I see some correlation with the type of company and the types of attitudes that I see relative to those companies that happen to have contamination problems. And then finally, we're going to close with some tenets on doing the right thing, and we're going to explain what the right thing is. Okay, getting right into it. How is contamination controlled? Well, two ways of doing it: proactively and reactively. Let's get into the proactive approaches first. Now, whenever you're trying to control contamination proactively, that means that you're trying to prevent or minimize the opportunities for contamination to occur. And these are actions that occur before the contamination actually becomes apparent. Obviously, otherwise it wouldn't be proactive. And we're talking about contamination possibly from raw materials or the components. But these often are controlled by specifications, and so you have specifications in a company that control how dirty or clean these particular raw materials and components are allowed to be. And this also includes the water and compressed gases. Very often, if it's something that's purchased, you'll get a certificate of analysis. And often what a company does is they will either repeat the testing on that or a portion of the testing or just accept it outright. Be careful of accepting it just outright without knowing, having some confidence that the C of A actually is truly reflecting the quality of the product. Now, this is an expectation for all components that are involved in GMP manufacturing, and if you look in 21 CFR 211.84D6, you will see it exactly saying that each lot of a component, drug product container, or closure with potential for microbiological contamination that is objectionable in view of its intended use shall be subjected to microbiological tests before use. And that means, basically, you got to test all these things to make sure they're going to be okay. Now, also, it happens that ICH, in their Q6A document, has a decision tree. It happens to be decision tree number 6, and that also addresses the quality control of the components that are involved. But if you look in USP, you're going to find that there's microbiological specifications only for some USP monographs, not all of them. And if you ever do buy things from raw material suppliers, you're going to find that in the C of A, only some of them actually list microbiological attributes. And so the question is there some liability gap here that exists between what are regulatory expectations, as written in the CFR, and actual practice? And the answer to that is, well, yes, there is. There is a big gap because it's open to the interpretation of what someone thinks might be something that is susceptible to microcontamination when they may not actually know what that susceptibility is. Some other proactive measures. Contamination from the processing activity must be controlled so that it does not affect the quality of the product, and this is often monitored with some sort of in-process monitoring. And as it turns out, this is also expected in the CGMPs, and that's section 211.110A6. And so in this particular case, they are referring to in-process testing of the materials, and this they're referring to bioburden testing, which is basically environmental testing and possibly in-process testing of the components as they're going through the process, or of the intermediates as they're going through the process. What has to happen is these good practices have to be extrapolated from the regulations to the production floor and then, of course, into SOPs, which make it official. And that in-process monitoring that occurs, often if it's just a physical or a chemical attribute of the product, it's done by production. But if the in-process monitoring is environmental or involves personnel, and usually this is microbiological testing, then you're going to see that being done by the micro labs. The training of aseptic or sanitary behavior of the employees should be done actually by the micro labs, and we're going to get into that as a key element actually. So let's look at reactive measures. Now this is responses that are elicited after contamination has been detected, actions that occur after the fact. And I'm not saying that these are bad, because if you do ever detect contamination, you must react and control it. It's always better to do it proactively than reactively, but sometimes the proactive stuff doesn't work, and we're going to get into that. So if it happens reactively, that means it's usually something that is implemented, often by QA, after the contamination is detected. And when does this occur? Well, it occurs sometimes when there are no proactive measures, and that means that there usually are no corrective and preventive actions, the CAPA, but only corrective actions that are occurring. So that means that the same problem can sometimes repeatedly occur. Sometimes you can also have intended to be proactive measures to prevent something from happening, but you're addressing the wrong thing. And so you may be missing the point altogether, and so the problem keeps recurring. This is a very large regulatory liability, and it means that you essentially have no functioning QA. All you have is a QC, and that is not what FDA wants to see. Sometimes it occurs when the proactive measures that are used are just insufficiently comprehensive. They may cover some of the areas that need to be addressed adequately, but others may not be hit at all. In fact, I've seen this very often in that a lot of effort is expended toward correcting the wrong thing and not what's the root cause. And so if you're not actually addressing the root cause, then it's going to occur again. And often when the proactive measures fail, you will see reactive measures. And this could be because maybe they weren't sufficiently stringent, or maybe they were vague, or maybe they were ignored and not carried out, either out of ignorance or out of convenience or budget limitations. The list goes on for the reasons why some things aren't done the way they ought to be done. Usually reactive measures will involve an investigation to find out what in the world's going on, and ultimately it will lead to a CAPA, a corrective and preventive action type of plan. And that means that once you have determined the root cause and you put your corrective actions in place and you determine the scope of the impact and all those things, you also put into place preventive actions. So even if you do have reactive measures, they lead to preventive actions anyway. But make sure that you follow up on your preventive actions to make sure that they're working. Very often the preventive action is addressing the wrong thing, and then that means that it won't be efficacious and stuff will continue to happen. So that's why you need to verify the efficacy of your preventive actions. Ultimately, like I said, even though you may have reactive measures to a contamination event, it should lead to proactive measures and prevention. So, proactive costs ultimately are smaller than reactive costs. But there's some reasons why sometimes this is not done. But ultimately it does save money. There is an immediate cost, but there is a long-term cost savings. And sometimes that immediate cost is what is the impediment, often by managers, of doing the right kind of proactive thing. Now, what could some of these things be? Well, it could be making sure you have adequate salaries for the adequate number of competent professionals that are in your laboratories and in your manufacturing units. That means, the adequate number part means that they have to have enough time to be able to do proactive measures. They cannot be literally working overtime just getting done with the routine stuff. They have to have some time, even if it is overtime, but not additional overtime, to work with procedural improvements to improve the facility, the equipment, whatever it takes to be proactive in preventing this contamination. Sometimes it means that you're going to have to foot the bill for the cost of some additional monitoring of whatever element in the process may be indicative of the control that you have over it. And this element may be controls in the laboratory. This element may be additional in-process monitoring. It's hard to say. It depends upon what the nature of the cause is, but it could be any of these. And it comes at a cost. It's not for free. But that cost is offset by your reduced rejects, by the reduced number of OOS and CAPA investigations that you have to mount, and these take huge amounts of resources to do this. And ultimately, it frees up and improves the productivity of manufacturing, especially when you can eliminate all of the downtime and all of the issues associated with investigating these deviations. Now, when you have reactive costs, sometimes these can be quite substantial. It can be the cost of rejected product. In some types of manufacturing businesses, the cost of one batch of product could exceed the cost of any number of people's annual salaries. And so just the rejection of product is a very, very costly thing. It also reduces the labor that's going to be needed for OOS investigations, and that typically isn't. It involves the laboratories, and it involves manufacturing, and it involves QA. And so if you want to reduce the total cost of your QA part of the budget, just reduce the amount of investigations that they have to do by doing some proactive measures. But it also leads to interrupted processing. And a big pharmaceutical company that has a major system that's down, like a water system, could lose $1 million a day in the cost of product that they're not able to make because, for instance, their water system's down. And then, of course, there's the cost of unsafe product, and that could be recalls, the cost of recalls, which are very expensive. More than one company has gone out of business and gone bankrupt because of recalls. The cost of them, the cost of litigation, the impact on your image as a company of fine pharmaceuticals. It could be many millions of dollars cost with these things. And then, of course, there's always the regulatory consequences of these ineffective reactive costs. And the resolution of these things, and it might require facility or procedural improvements that are in an emergency nature rather than a planned nature. If it was proactive, it would have been planned out and executed. If it's in a reactive situation, you may be forced by FDA, if you want to stay in business, to do a major renovation of the facility, and that means that the whole facility is shut down for some period of time while the renovation is occurring. And you could have suspended or limiting manufacturing until the resolution is completed. And all kinds of issues. Suspended new product approvals. If you happen to have new products in the pipeline, FDA will suspend review of those applications until you solve your problems. And, of course, if there's any kind of criminal fraud that's involved in some of these things, there will be prosecutions and jail time. You might have a site license revoked, bankruptcy, who knows what. And so the impact of having just reactive measures is quite substantial. Your best investment, therefore, is going to be in preventing contamination from occurring to begin with. It does pay off in the long term, but sometimes it is difficult to see in the short term. It looks just like a lot of money being thrown into something, and that's because it's hard to define the return on investment when you're comparing the cost of preventive activities to an undetermined, unmeasurable cost of failure. And so budget managers often don't see the value since the risks, the quantitative and the cost of the risks are sort of vague and hard to put in terms of numbers of dollars. And so budget managers often don't allow proactive costs to be expended because they can't see the value. So why should the micro lab lead in contamination control? Well, you know, it's an uphill swim, folks. QA is the typical leader when it comes to contamination control, especially in the investigation part. But unfortunately, QA often does not have the specific microbiological expertise to effectively plan or assess the contamination that occurs, let alone the preventive actions that would work. QA is already a very busy organization. They are consumed by the 21 CFR tells them that they have to be involved in oversight of all functions on site. And so they are consumed with the paperwork and that site oversight function. They are very busy with deviation investigations and reactions to those. They are very, very busy people, especially if you don't have a lot of proactive measures going on, so they're reacting all the time. Very often the QA personnel are not microbiologists, and they have very little microbiological training. Now, there could be personnel that used to be in the laboratory that were laboratory technicians in microbiology that move over to QA. That does not make them microbiologists. It means that they have a passing knowledge of the tests, but they don't necessarily have a thorough understanding of what I call microbiological good manufacturing practices. They often have just a set of paradigms or a set of rules that they think they can live by. And if you live by a set of rules in that way, sooner or later you're going to do something wrong because there wasn't a rule for it. And a microbiologist would automatically know. So QA often does have paradigms and standard ways of dealing with material handling and containment, gowning and aseptic behavior and so forth, but they don't necessarily understand the reason behind them. They just are rules to them. And so when they're just rules to them, they have a difficult time trying to convince production of the value, as well as trying to enforce those activities when the rationale is really not adequately explained. And it leads often to an inconsistent mix of unnecessarily strict and perhaps lenient practices. For instance, if you've got a really, really seriously onerous practice that you're expecting manufacturing to do, it's going to lead to non-compliance. For instance, expecting partial gowning when someone is in an uncontrolled area, doing some kind of activity in an uncontrolled area. That's ridiculous. The area is so uncontrolled that some partial gowning of the people has very, very little to do with the quality of something. Now, possibly glove activity because you're directly touching things, but even use of gloves can be improperly implemented. If you tell someone that they need to use gloves, but you don't tell them about glove sanitization and you don't train them about proper gloved behavior, then the glove just becomes a second skin and they touch everything with the gloves, and so there's no benefit of using gloves for handling something. It's only through the use of gloves that are sanitized often, especially after touching something dirty, before then touching something clean, that the glove has some kind of benefit. So, why should the lab be the leader? Well, the lab personnel in the micro lab should be, at least, true microbiologists, not just people who know how to run micro tests, but I'm talking about really understanding the microbiology of the organisms that they're looking for, of the products and whatnot. They have a microbiological education with expertise and experience that allows them to understand the ecology of the various organisms, what normal flora is for various situations and various habitats, and that could be contamination sources for products. They understand how the manufacturing practices can be executed to minimize the possibility of contamination. They know the proper technique for donning gowns and gloves and whatnot, and why. It's not just a procedure. There's a why behind how it's done that way. They know the antimicrobial properties of materials and processes. They also know the consequences of contamination, be it the consequences to the product or medical consequences to the users of the product. And they understand the issues associated with the users, like their age, how the product is exposed to them, and other kinds of medical factors that could compromise their immunity. They understand this because they've studied this in school. Often this leadership will come from a single individual from the laboratory. That individual may be the senior person, such as a supervisor. It may be the most knowledgeable technician that's been around for the longest time in the laboratory. These personnel, these laboratory people in the microlab, are experts in the tools that they are using to assess the quality of the facility as well as the product. They understand how the tools work. They understand how the techniques work. They are skilled at their use, and they know how to execute them uneventfully. They also know what they are not capable of doing. And so they are also aware of the other tools and techniques that are typically available in contract labs that may be beyond the capability or cost of having locally in their own laboratories. They understand the limitations of the techniques. They, for instance, know that most microtechniques have to be qualified to be suitable for their application. If you suddenly start testing a new product or a new material, that's an in-process material, you've got to qualify the method to make sure that the material is not inhibiting the growth of organisms that could be there that you want to detect. They understand the accuracy and precision, or I should say inaccuracy and imprecision of the test results, because most microtests are a little bit on the inaccurate side just because of the nature of bugs. They are not uniformly distributed, and so it's sometimes very difficult to get good, accurate test results whenever you're analyzing a material. They know where the sources of self-caused contamination can come from in the process of running the tests. And so they know what monitoring and controls can best be used to detect their own contamination when they're performing the tests. They know how to interpret the results of the tests. They know the imprecision of the data, and they know what that means. They can understand also, because they're the ones doing the work in the lab, and they understand what the workload situation is and the sample throughput situations are in the laboratory, and can actually dovetail things into existing things that are already being done to get the best efficiency out of the laboratory. They know where to look for these external contaminants, and they are very much aware of the industry expectations for conformance as well as the regulatory expectations. So when it comes to evaluating the contamination, the microlab's already performing this testing. They are very often with some types of materials that are very prone to contamination, especially when they're being collected. They often are the ones who are also collecting the samples that are tested. This could, for instance, is for environmental monitoring and water compressed gas monitoring. These are almost always, the sampling is almost always executed by the same laboratory people who are then further processing those materials when they get back to the laboratory. However, raw materials and product bioburden testing, they perform that testing, but the samples can be collected by anybody. The microlab is also involved typically of doing the identifications of the organisms, any challenges of product, or the test methods or the media, and also evaluation of the sanitizers that happen to be used. They know how to be able to add special testing to the routine testing, so there's only a small incremental increase in the workload, because they already know what the work plan is going on through the various days of the week, and they know perhaps what day is best for collecting a certain kind of a sample. The QC lab is already doing trending of the results. Now, the trending is done two different ways, a non-preferred and a preferred way. The non-preferred way is the data is not actually graphed. It may still reside in tables of numbers, and any abnormal trends in these numbers tend to be detected by either a skilled observer or someone who's been doing the test for a long time and says, hey, we don't typically have numbers that high for this stuff, so they may know what's going on. And so it's not technically graphed, but they still know that the trend is there. This is a pretty common practice, but unfortunately it's very personnel dependent. And it depends on who's looking at the data, how much experience they have, and unfortunately, because it's going to be variably executed, oversights are going to be likely. So what you really should be doing, the preferred way, is to trend your data, to graph it, and to set up historical trend-based alert and action levels that can be used to tell anybody who looks at the data, say, hey, that's out of trend. We're above our alert level there. And, of course, it means that someone's got to set up meaningful alert and action levels. But it winds up being personnel independent, and so oversights become unlikely. But remember, it's only as good as the alert and action levels that you set up. Now remember, an action level here is not a specification. It is only something that tells you to take action. And there's great confusion over what an action level is supposed to mean. But the technical benefit of alert and action level is that they are trend-based, and they tell you when that something may be trending out of trend or actually is out of trend. The microlab is the first to know. They're the ones who read the plates and say, uh-oh. So they're the first to know that something is amiss. Now, when it comes to microbiological training, the folks in the microlab should be the undisputed owners of on-site microbiological training. There should not be just contractors that come in and do the training. These microlab people need to be the ones doing it for several reasons. They can train, let's call it sanitary awareness training, if you happen to have a non-sterile operation going on. And it should be executed for both the operators and their management. The managers of these non-sterile processes should also attend this training in every case, no exceptions. And of course, if there's aseptic awareness training that has to occur for the sterile process operators, their management should also be present. If there is microbiological method training that has to occur, and of course there is, it's done by the micro people for the microlab analysts, the ones that are new to the process, they're just coming on board, learning how things are done. It's also done by the microlab. And whenever there is training for investigations of microbiological deviations and interpretation of data, then that should also be done by the microlab for the QA people, because the QA people are the ones who ultimately are going to be involved in the interpretation of the data as well. Many an overreaction has occurred by a QA organization because they did not get this kind of training. So this can be supplemented with off-site courses, but it is very, very important for the local production microbiological awareness training to be done by the QC Microlab for several good reasons. The training is by comrades, and training by comrades builds camaraderie. It also demonstrates the expertise of the in-house microlab and their value to those who are being trained, because they are aware that these people actually know what they're doing. You can execute this training in a fashion that actually shows the impact of bad manufacturing practices, of bad personal practices, and it can show the ubiquitous contamination that's all around us but cannot be seen with the naked eye. This is very often done in dramatic and sometimes gross fashion by looking at swabs from contaminated surfaces, finger plates, and all this kind of stuff. And I can tell you that is fun and unforgettable for the trainees because they are certainly unaware of all the organisms that are living on them and around them. And so it winds up being a very memorable experience that they will not forget. The ubiquity and grossness of the contamination that we swim in every day will become very much a part of their awareness, so that they will have a much better appreciation for the purpose of being sanitary and hygienic about their activities. It does drive home that fallacy of out of sight, out of mind. Because you can't see it doesn't mean it's not there. And they will find that out very dramatically. The training also facilitates future communication and cooperation. You sort of establish the relationships during the training course between the trainer and the trainees. Often the trainees are the manufacturing people. And so there is a potential for future cooperation and communication that occurs. It also facilitates, and this is actually very good, it facilitates the awareness of particularly manufacturing people who are not microbiologists that there are limitations to the tests. The limitations also often are the incubation period associated with allowing the organisms, the contaminants, to grow into something that's visible. And so this can be used as sort of an opportunity to reinforce the value of rapid microbiological methods that don't require this very long wait before you actually see results. And so whenever manufacturing people see the value of rapid micro methods, they may actually be encouraged to perhaps contribute some of their budget money to facilitate the micro lab having a quicker test result, which benefits manufacturing. Anyway, just remember that this training that these people undergo does not make them a microbiologist. It gives them microbiological awareness. It allows them to use microbiologically wise behaviors, but it does not make them microbiologists. So when it comes to investigating these sort of deviations in contamination events to try to find the root cause, the microlab people are uniquely equipped for these investigations. They have the ability, because they understand the subject, to develop an investigation plan to try to find out the sources, because they know the potential sources based upon the types of organisms that are recovered. They know where they can come from, they know where to look for them, and they know the most successful techniques that can be used to recover them from these sources. They also have the ability to interpret the data that is coming in from the investigation and its impact, because they will know the susceptibility, for instance, of the test methods and controls to extraneous contamination. They should know that anyway. They will know the limitations of the methods, be they quantitative or recovery limitations, and they will understand the contamination susceptible behaviors that can be used by production operators, and will know exactly where to look for these kinds of behaviors or where certain operations are performed that could be prone to contamination. They also have the capabilities to know about the contaminants and whether or not they will grow in or degrade a product, whether or not they're going to be resistant to preservatives, and they will understand the medical problems that could be caused by certain kinds of organisms, or even product problems that could be caused by certain organisms because of the composition of the product, how it's administered, and so forth. They have pre-existing communication lines with a number of departments. A lot of this, by the way, is facilitated by the training I talked about. But they'll have these communication lines with production departments, with the QA organization, with regulatory affairs, the folks that have to interact with FDA and send in new product applications and all that. They know the regulatory expectations. They read the gold notes and all these things. So they know what the regulatory expectations are, both of FDA and internationally. They also keep up with warning letters and 483 observations. They understand the products that are there and the patients that are using them and the types of contaminants that could be problematic associated with those products. They actually have the microbiological conscience of the company, and they exercise this all the time, unwittingly, because there is all the time pressure to have a test result sooner than is possible because of the incubation period. And so they have great experience in resisting the pressure of making a hasty or perhaps a favorable conclusion because they understand the nature of the test and what its limitations are. They have that best comprehension of the test limitations and capabilities, the contaminants, the impact on the product and patients, compliance issues. They understand all of this. So with all of these positive things and all of these things that just reinforce the fact that, yes, the microbiology lab personnel should be the ones that are leading the charge in investigating and mitigating contamination and preventing it from happening, there are impediments to them being able to do that. Sometimes very serious impediments, and we're going to look at what they are. The reasons that they are not allowed to take a leadership role are often by many excuses or reasons that may be motivated by traditions or paradigms. Notice the red letter T. That's a code letter T, so it's standing for traditions. Capability or competence, or incapability or incompetence, and that's the red letter C. Sometimes it's ego motivated, that's E, and sometimes it's fear motivated. And unfortunately, I've seen it often, it's laziness motivated. So we have the T, C, E, F, and L types of excuses or motivations. So what specifically are the common reasons or excuses why the QC Microlab should not or cannot be the leader of contamination control? Well, the labs are not allowed by QA to lead. Now, this is perceived because it's traditionally been the QA function and not the microlab. And so there's the T, the traditional issue. Then there's this fear of non-compliance with regulatory expectations, this thought or this perception that it's supposed to be QA that leads. And so there's a fear of non-compliance. There's this loss of control that QA would have over QC and manufacturing and the consequences of the investigation. So therefore, there is ego involved in this. And also, this could be perceived, if QA delegates this to the microbiological QC lab, it could be perceived as an admission of lack of expertise. And that's an ego thing as well as a fear thing. So, here's some more. Resource constraints. Oh, gosh, have I heard about this one. So, it could be that maybe the folks in the microlab truly are not microbiologists. They don't have a good microbiological education or training or experience. And I have seen this be the case. And so we have a capability issue here. It is a good reason, but it should never happen. There should never be a microlab that doesn't have a bona fide microbiologist in it, at least one. Now, sometimes this winds up being forced by budget limitations because you can't afford to pay experienced staff. So you pay somebody who can spell the word microbiology but is not a microbiologist. And you'll see this when the staff is inexperienced. Even if they do have a microbiological education, they may not have much experience postgraduate. You know, after having gotten their diploma, they may just not have a whole lot of pharmaceutical experience. And their routine testing may actually be questionable. And if that's the case, yes, they do not have the capability for leadership. What about resource constraints like, for instance, the microlab people are just consumed with the workload and they can't take on existing, more responsibilities? Well, this is a capability issue, but it's also a fear issue and also a laziness issue. Who is the one that's pronouncing this, that says that they cannot take on more workload because they're already busy? They may very well be. They may be overworking right now just with routine things, and that's a possibility, but it could also be a fear and a laziness issue. Often it's forced by budget limitations because you've got reduced staff, and so now you've got fewer people doing the same work that more people used to be doing, and so they just don't have time. But it's also pretty short-sighted planning and resource utilization. Ultimately, it takes less labor to do proactive measures once than it does to repeatedly react to the contamination over and over and over. And there is a regulatory liability that you have with unresolved repeating problems. It's also a pretty poor excuse because there is no hesitation by senior management to add reactive investigational testing to an already full workload in the laboratory. No resistance whatsoever, no hesitation. So they will add to a full workload all kinds of investigation testing, and this winds up becoming routine overtime. Now, a little bit of routine overtime financially is not a bad thing, but when it's excessive, then burnout is likely. And whenever burnout is likely, you're going to have overworked technicians that eventually say, hey, listen, I could transfer over to that lab. They're not working nearly as hard as we are. And so you lose the people from the laboratory as they transfer over to other laboratories or other departments. Very often you'll see technicians who are close to burnout transferring to QA. It's sort of ironic. But anyway, what happens is that when they leave, the workload increases for who's left. And so things get even worse for the people who are left behind. Now, you could hire people in, but everybody knows that when you hire people in who are not familiar with the work, it takes some period of time before they become efficient enough to actually relieve the workload. It actually adds to the workload when you're trying to train people to do the testing. And you're taking away the time that the trainer would spend actually doing routine testing. And so it becomes a worse situation. You're better off having people who can stay around for a long time and love their jobs than burning them out and forcing them to leave. Sometimes, and I have seen this actually a number of times, you will have a non-microbiology supervisor, someone who is not a microbiologist, and more often than not, it's a chemist that is now in charge of the micro lab. They may also be in charge of the chemistry lab, so they may be in charge of both labs, or you may find that they are in charge of just the micro lab. Very often I have seen this perceived as punishment because they don't really like that stinky lab over there, that micro lab, and so it affects their attitude and their motivation to do a good job and to learn enough microbiology to do a good job. So it's an ego thing. Sometimes there is a lack of effort in proactive prevention of production contamination because the managers that are thrown into this situation that really don't understand what they're working with have very little knowledge of what the probable causes. And so there's a capability issue because the managers have only a superficial knowledge of microbiology and not enough to understand how to mount a successful investigation. Sometimes there's a fear of demonstrating their own microbiological ineptitude, and so there's a fear factor associated with the lack of proactive prevention, proactive activity going on to prevent the production contamination, and sometimes there's a lack of confidence that they can pull us off and look good, and so there's an ego thing. And very often you will see the excuse, oh, we couldn't possibly do that. We're so busy. We're just so busy. We couldn't possibly get involved in any kind of proactive work. Sometimes the supervisor's perception is that the micro lab is just a testing machine. They're just like the chemistry lab. Their job is doing the test. Their job is not thinking. Their job is following SOPs and executing procedures. And so there becomes this capability issue, and it could very well be that the people are so busy doing the testing that they don't have any time to do anything but the routine testing. So there's a possibility of this capability thing, but also it's a misperception by the supervisor that that's all the lab can do. Not my job. Boy. It angers me when I hear that, but whenever I hear a supervisor of a microbiology lab say, you know, yeah, but that's not my job. My job is testing. In actuality, it is their job. And so the not my job word is a cop-out. It means that they're probably not willing to take on more work, so there's a laziness issue there. It may require them to learn this stinky micro stuff, and so there's an ego and a laziness issue associated with that. And it could also be that fear of failure in this high visibility role within the company, and so there's a fear factor there as well. Sometimes the labs are not allowed by production to lead in contamination control. And this is because there is an adversarial relationship that already exists between production and the quality departments in general. Production has traditionally disliked and mistrusted QA and QC. They're the ones that always give the bad news. We don't ever hear from them when there's good news, but boy, when there's bad news, we hear from them. And so there's this traditional perception that they're the bad news boys or girls. There's the production perception that the micro labs are incompetent, and they're the cause of the problem. Couldn't possibly be manufacturing. It's obviously the micro labs that screwed up. So there's this capability perception. There's this happens whenever you have QA that doesn't know what they're telling people to do. Or doesn't understand what they're telling people to do. And so production gets forced to do ridiculous, costly activities by QA. And so there's this issue with capability as well as ego that comes into this. Well, I am not going to have those guys tell me what to do anymore. And so I often see this adversarial situation develop, especially when production thinks that they're perfect and they couldn't possibly be at fault. And that is definitely an ego thing. So when you've got this adversarial relationship between production and the micro labs, you've got to understand and reverse the causes. If you do not neutralize these attitudes or at least soften them, you will never have a hope of success in cooperation. But if you can, both sides will be less defensive. Both sides were going to realize that they have a common goal, which is higher quality of product, less overwork, less overwork, a better bottom line, which means maybe we'll get, a bonus at the end of the year. And there's actually fewer regulatory liabilities associated with this, which take up time. So both sides are going to be more likely to be forthcoming with important information that's not written down in batch records or not written down in test records, but information that may be helpful in understanding what's going on. The lab's expertise is going to actually be more noticeable and appreciated rather than having this brick wall relationship between the two. And what will happen is the most competent side is going to become the natural leader of this process. So who knows more about contamination control? Is it production? Or is it QA? Or is it the microlabs who understand contamination? It's the microlabs, of course. So this adversarial relationship is probably one of the most serious impediments to the microlab taking on the leadership role in contamination control. And in order to overcome these, the lab really must take the lead. And they must overcome these perceptions that are bad perceptions that manufacturing has. And that is the data always takes too long to become available. Whether it's good news or bad news, it takes forever to find out what the news is. And if the contamination is detected, the lab never admits to being at fault. It's always production's problem. The lab is perfect. Yeah, right. But the finger always points at production, not the lab. And production gets tired of that when they know or suspect that the lab may not have done something correctly. And very often that is true, actually. So the lab must engender some alternative perception of, for instance, slow data. So how can it do that? Well, it can simplify the data approval process so it doesn't go through such an arduous path before it becomes official available data. Maybe production can be made informally aware of the latest interim test results, even by a phone call, even though they cannot officially act on it. Sometimes when you can see a TNTC, or too numerous to count plate, that's in the process of growing and hasn't completed its incubation yet, you know it's going to be TNTC. And so maybe you can let production know sooner rather than later about that so they can start taking action. Maybe you can discuss the value of rapid microbiological methods for faster results, and maybe have some budget sharing issues going on because production benefits from that. It's not just the labs that benefit, it's production that benefits. How about this perception of blame? The production is always perceiving that the labs are at fault, and the labs are always perceiving that production's at fault. So if the labs were to inform production whenever there is any kind of excursion data immediately, rather than waiting until after they've done their little internal self-evaluation, but let them know immediately that we've got an excursion result, and quickly and publicly say that the investigation is ongoing, and it might very well be the laboratory, but they're going to investigate the lab as well as manufacturing to find out where the most likely source is. So publicly admit that it might be them. It might be the laboratory that may be the fault. That'll go an awful long way toward neutralizing this perception of blame. The lab must not overreact to production's accusations. The lab has to realize that production has been accusing the labs of being the problem for, well, ever since there were labs. And so it's a habit, and it's something that has to be stopped, but you can't have a thin skin about these kinds of things, so don't overreact, laboratory folks. The lab must do their own work, however. They must implement revealing environmental monitoring and revealing manipulative controls when they are doing their routine sampling and testing. Now, we're not talking about putting one settling plate in the hood, shoved up way away from where the work is going on, testing the quality of the air that's coming through the HEPA filter. That's not what we're talking about. What we're talking about is putting these exposure plates where they could be exposed to contaminants that are dripping and flying off the sleeves and wherever of the testing technicians. That's the place where the plates need to be. Excuse me, my cold's acting up here. And so we're talking about putting exposure plates between the technician and where they're working. And yes, they could drop organisms onto it. That's a good thing, because if you don't have the organisms recovered on your exposure plates, you don't have anything to compare the isolates from the test to find out if they perhaps came from the laboratory. Same thing during sampling, especially sampling in uncontrolled environments. Whenever you're doing sampling of water or even of products in an uncontrolled environment, the environment can be the source of the contamination. And so you should do some sort of environmental monitoring while the sampling is occurring. And if you happen to have a lot of strange organisms that you know shouldn't or couldn't have come from a source, for instance, finding gram-positive spore formers in a water sample, well, that's not possible. That's coming from the environment. Well, maybe you ought to do some environmental monitoring while that sample is being collected. The lab must allow production into it. The lab has to allow production to view the testing. It cannot be a one-way street where everybody can look at how production is doing their work, but no one can look at the lab. And the excuse of, well, lab people are contaminated, we don't want them to come into the lab, that's a bunch of hooey. If the contamination is that likely, then chances are that testing is being done in a very controlled situation, like in a little mini clean room or in a hood or whatever, and you can stand outside of that hood and look in and see perfectly well without contaminating what's going on in the test. What's good for the goose is good for the gander. In other words, if it's okay for production to be scrutinized and their training records to be scrutinized by QA and the labs and all this kind of stuff, then the opposite ought to be true as well. And so the laboratory should be open to equivalent scrutiny by manufacturing if they so choose. And it will mean that they basically have nothing to hide. It's a way that the lab demonstrates that there is nothing that they're trying to put under the covers. So, the lab has to emphasize they're on the same side in reducing contamination as manufacturing. And they need to be putting proactive measures in place, preventive measures, doing the right kind of training and doing the right kind of investigations. They need to truly correct the root causes, no matter whose shop it's in. If it's a sampling problem, correct the sampling problem. If it's a testing problem, please correct the testing problem and admit to it. Nobody's perfect. If it is a manufacturing problem or the behavior of even one employee, even though other employees doing similar jobs may be doing it well, maybe one employee is not. It's a well-known fact that some individuals tend to shed organisms more than others, and some tend to shed specific objectionable organisms. And if that's the case and you find out that one person is a shedder, I mean, it's not their fault that they're a shedder, although if it's shedding because of poor behavior, that's something else. But people could, may need to be redeployed in a particular job function that's not an objectionable thing. It's nobody's fault, but the right people need to be doing the right kinds of jobs. The lab must be willing and able to do the additional testing or the additional controls that are necessary to support whatever recommendations are necessary to be proactive in preventing this contamination. Now, I mentioned earlier that I have been consulting for a number of years and been observing and helping people with resolving contamination problems. And I have put together a list of things that I have observed that tend to correlate with companies that are having contamination problems. Sometimes there's not so ironic that these correlations do exist. For instance, whenever there is a company that is involved in the manufacture of a very high volume and low margin product, and they're doing so on a limited budget, and these are usually your generic companies, your OTC companies, and sometimes contract manufacturing companies, not always, but sometimes them, then I see contamination problems a lot in these kinds of companies. These kinds of companies typically are far more concerned about productivity and profitability than they are about product quality. They figure the product quality is good enough, but they have to make a profit also. Sometimes these companies are have been recently involved or are currently involved with some recalls, product recalls. And very often the reason for me coming on board to begin with is that they are under FDA scrutiny or perhaps regulatory action of one sort or another because of these particular behaviors and emphasis on productivity rather than quality. I've also seen this happen a lot in companies that don't have their own microlabs, or in those that, if they do have microlabs, are literally a closet where they have under-equipped and underpaid people who are also overworked doing the micro-testing. And invariably in these situations, there's a very high turnover. There are training issues and competency issues with the people who are executing the procedures, and sometimes also language issues. And you can take that for what it's worth. If they do have a micro lab, they often do not hire experienced, degreed microbiologists that have pharmaceutical microbiology experience to manage and staff the labs. They typically have such tight budgets that they don't send people to training courses or to conferences because they feel that they can't afford this external training or expertise that their people may gain. They hardly ever benchmark with other colleagues in the business, and part of that's because there's a fear of perhaps exposing their own bad practices, or perhaps of revealing something that they're doing that gives them a competitive advantage. And so they just don't benchmark. They don't let people know what they're doing. They don't try to find out what other people are doing, because in order to find out what others are doing, you have to share what you're doing. You know, you show me yours, I'll show you mine, that type of thing. And often I've also seen that the CGMPs to these companies wind up being a set of rules, a set of check boxes, and not just a corporate culture or a corporate attitude. When it's a set of rules or check boxes, there will invariably be problems, contamination problems. So you wind up having to really do the right thing. So what are some of these right things? So, regardless of the impediments, doing these right things will invariably lead to better contamination control, like having your own on-site microlab, properly staffed, of course. Now, is a contract lab an option? Yes, it is. A contract lab, especially a competent contract lab that's willing to work with the firm and sort of really understand their processes, It's almost like they're off-site contractors that are doing the work of an on-site microlab. And so they work with the company almost like they're employees of the company. If it is a type of a contract lab situation where you send the samples and we send you the test results, then that's not a good relationship. It's not intimate enough to be of value. However, a contract lab can be an option even if you do have an on-site microlab for doing those kinds of tests that the on-site lab just does not have the capability of doing. And this could be microbial ID, it could be some elaborate, expensive test that they're not set up to do, or a test that's not done very often. Make sure that they hire educated pharmaceutical microbiologists, especially the supervisor. Now, emphasis on pharmaceutical microbiologist. If someone is a medical technologist, they're not a pharmaceutical microbiologist. If someone is a food microbiologist, they're not a pharmaceutical microbiologist. If someone is an immunologist or a cell biologist, they are not pharmaceutical microbiologists. You need to hire someone who actually has experience in the pharmaceutical business, not the food business, not the hospital lab, not gene juggling biotech company. True pharmaceutical microbiology, especially the supervisor. There needs to be a continuing education program for the laboratory staff. Not only does it improve their education, obviously, but it also is taken as a perk because they actually get to leave and they get to see other people and they get to see how they do things and they can bring things back, new ideas that they learn from other people. It's a win-win situation to have these continuing education opportunities. The lab, like we've talked about for this whole presentation, needs to be empowered with the leadership in microbial control for the site. These folks are the ones who know how to do it, should be the ones who know how to do it. You need to hire the number of permanent micro personnel that can address not only the routine workload, but have enough time to spare for these prevention activities, to implement these prevention activities. If you cannot do that, then the laboratory is not going to be suitable for this. You need to make sure that both the laboratory and manufacturing have the right kind of equipment to be able to do the job correctly. I've seen many a microlab using archaic, absolutely archaic testing equipment, using archaic autoclaves to do their microlab stuff. They're so inefficient. Or the manufacturing process is so prone to contamination that, you know, buy the right equipment that'll do it right. Just bite the bullet and get the right stuff in so that you can do it uneventfully. Use prolific and meaningful controls and environmental monitoring when you are doing your testing and sampling. I talked a little bit about that. I can't emphasize it enough. If you don't have the controls that will reveal the contamination that's occurring during the testing process or the sampling process, then manufacturing will always be blamed because the data does not support that the laboratory did it, even though the laboratory did do it. So make sure you have a lot of controls that will reveal the quality of the testing that's being done in the laboratory. Only then can you actually justify pointing the finger at production whenever you have no evidence whatsoever that the laboratory was at fault. Trend the data so that you can detect developing problems early. Proactively institute these contamination-reducing procedures. They may be procedures that involve just more exhaustive flushing of water samples before you get a sample. Now, keeping in mind, if it's a point-of-use outlet, manufacturing also has to flush the same way in the same fashion and all that. That's a whole other webinar there. but it could be a contamination reducing procedure to just have a more thorough flush before you get the sample, or just have more proactive use of alcohol on your gloves in order to avoid contamination. Train the production staff, and we're talking the operatives, as well as management, in good microbiological practices. Implement effective corrective and preventive actions. Maintain open, informal communication lines with production. Informal. It's important to have informal lines as well as formal lines. The informal lines, pick up the phone, you let somebody know, they really appreciate knowing. Overcome or neutralize the negative attitudes that you might have about another organization that you need to work with in order to solve these problems. So overcome that. Get over it. So now we've gotten through all the things I was going to talk about, and I can say that my part's over except for the question and answer part. So, do we have any questions?
Thank you so much, Terry. Thank you for the presentation. Ladies and gentlemen, like Terry just said, we'll go ahead with the question and answer session. So if you do have any questions, ladies and gentlemen, this would be your time. What you could do is, if you have any verbal questions, you could just go ahead and click on the raise hand option, which is a palm-like icon on your participant screen. And then I should be able to unmute your line. You can post your questions directly to Terry. Or in case you have questions as well, you could always post them in the Q&A panel. Or if you're not able to do either of the two, you could always send me or Terry a chat message with your question, and we can have them answered for you. So if you have any questions, ladies and gentlemen, please do go ahead. And while we wait for any questions, ladies and gentlemen, I also want to just keep you informed that the feedback form is open in the polling panel. And we would really appreciate your feedback on today's session. It's got just over 8 questions, and they're all multiple choice in nature. And it shouldn't take you more than 2 minutes to go ahead and answer them. So we would really appreciate your feedback on today's session. And if you have any questions as well, please do go ahead. And at the same time on screen, you can see the webinars which are available on recorded format for Mr. Solly. And even today's session is available in a recorded format as well. So if you are interested, you could always give us a call or log on to our website, and we should be able to assist you. And these are few of the recorded webinars which are available. There are more which are on the dedicated page for Mr. Solly on the Global Compliance Panel website. And these are a few of the upcoming webinars as well. And even in the presentation slides, you have the link at the bottom. So if you do want to visit this page, please could just click on the link provided, and you should be able to directly go to the website. Terry, I don't see any questions coming up today.
Okay, well, I want to thank you all for patiently listening to me, and I'm hopefully excusing my occasional coughs and sips of water. I enjoyed the presentation. I hope it was meaningful and gave you some information to work with when you go back to your jobs. But again, as Michael has mentioned, there's other materials that are available from Global Compliance Panel, as well as some upcoming webinars on some subjects that may be of interest to you. And I look forward to hearing from you or seeing you. By the way, if you were a little tentative to ask questions out in front of everybody, you can always send an email to Michael or Global Compliance in general, and they can forward that question to me, and I'll be happy to answer it. But that's also available to you if you think of something, you know, in the next few minutes after we're done. So again, I enjoyed it, and thank you for participating.
Thank you so much, Terry. Ladies and gentlemen, like Terry said, on screen you could see the numbers which are available if you want to give us a call. The number is 1-800-447-9407, or if you have any suggestions on today's session as well, you could always write in at the webinars@globalcompliancepanel.com. Ladies and gentlemen, like Terry also said, if you have any questions which you could think of later in the day, you could always send an email to myself or the Global Compliance Panel team, and we will have that passed on to Terry to get you an answer. Ladies and gentlemen, I'll go ahead and conclude today's session. I really do appreciate all of you participating, and thank you all once again, and do wish you all a lovely evening ahead. Terry, thank you so much.
You're very welcome. Thank you, Michael. Everyone have a good day.
Take care of yourself. Yep. Thank you. Bye-bye.